All right, we're going to be looking at the parallelogram here. So first, before we look at some of the example problems, I just want to take a look at Walt, the parallelogram, and just give you a few reminders about some of the properties for the parallelogram. So remember, based on the definition of a parallelogram, we have opposite parallel sides. Okay, that's the definition. And then one of the first properties was that we had opposite angles that are congruent, A and T, W and L. We also have opposite congruent sides. And then some of our other properties had to do with, actually, I'll just go ahead and leave those marks on there. Some of our other properties had to do with creating alternate interior angles. So when we created this diagonal here, so we have this diagonal here, WL, this diagonal here, AZ. They bisect each other. So I'm going to put a congruent mark here and here, here and here. And also, since this is a parallelogram, we have opposite parallel sides, we should have some alternate interior angles that are congruent. So I should be able to say these angles here are congruent. They are kind of inside that Z shape, alternate interior. These angles here, they are congruent. Put 2 little marks on them. And then our alternate interior angles at the other opposite corners here. So like maybe 3 marks on that angle, 3 marks here, and then just put a little dot on the last angles that are congruent to each other. Okay, so let's go over some of the example problems. So in this diagram here, we know that our opposite angles are congruent, so that should help you solve for y. And then we also know that same side interior angles are supplementary. So I would say that angle W plus angle X is equal to 180. And you should be able to use that once you solve for X. You can then solve for angle Z. Okay, on question 2 here, we have essentially this angle 24, which is congruent to this angle here. And you can create the Z shape out of that to see the angles that are inside the Z shape and therefore congruent to each other. Okay. And then we have our other set of angles that are congruent as well. So this angle 32 would be congruent to this angle y minus 10. You can see the angles are inside that Z shape there. Now, in this diagram, kind of like what we were looking at up here, is we know that these angles next to each other, remember we call them same side interior angles, same side interior, equal or supplementary, we'll put, which means they add up to 180. Okay, so I would be able to take these two, and you know that they're the same side interior angles when you can kind of create a little C shape, like a little bracket here with them. So you're going to want to add these two angles to equal 180. And once you've done that, you're looking for also the measure of angle 1. So you're going to solve for x, get your solution for that. You can check it in Edge Elastic. And then you're also going to solve for angle 1. So angle 1 is, remember, opposite and congruent to this angle here. So you're going to use a little substitution, and you will plug it x value in here. Okay, question 3 has to do with our diagonals being congruent and all of our sides being congruent. So you first might want to place congruence marks on opposite sides. Remember, these two sides here being congruent. And then we also know that the diagonals bisect each other. So QT would be congruent to TS. PT would be congruent to TR. And actually, I need to place a different number of marks next. I already have one mark there. So I'm going to do 1, 2, 3, 4, and 1, 2, 3, 4. There we go. Okay. And then in our last problem here, we just have our opposite sides. We know these are equal to each other. So you can just create an equation where we state that they are equal.